Hi, welcome back to Moose and Chemistry. This lesson's on equilibrium in the ice tables, lesson F. Okay, in this case, the other problems that we've been solving, we didn't know what the KEQ is. Now we know what the KEQ is. The KEQ in this equation is none other than, of course, 1.2 times 10 to the negative fifth. All right, so now we know that. So this is a little bit different than what we've been experiencing before. So let's go ahead and clear that out, and let's go ahead and get started. All right, first of all, remember that KEQ is products over reactants. That's very, very important to remember, okay? All right, now, we're going to want to look at our equation here. Is this equation balanced? I don't think so. We have 3 oxygens on the product side and 2 oxygens on the reactant side. So we kind of need to fix that real quickly. So to do that, we're going to put a 2 here. But when we put a 2 there, we also have to give nitrogen a 2. So let's give nitrogen a 2. Now we have 2 nitrogens on either side, and we have 4 oxygens because it's 2 times 2, and we have 2 oxygens here and 2 oxygens here, which gives us 4 oxygens. So we're balanced. Okay, so great. So now what we want to do is we want to set up a ice or rice table. So again, we're going to go ahead and we're going to go make our table. It's really, really important to do, by the way. Okay, so we're going to go R, I, C, and E. There we go. And now we have 2NO here. We have 2NO here. And we have O2 here. Well, let's look at this. Our original concentration was 0.50 mole of NO2. We don't just have one of them, we have 2 of them. So what we're going to have to do is we're going to take 0.50 and divide it by 2. And when we get this, cancel this out, this would give us 0.250. So that's going to be our initial concentration per every mole. So we have a mole of a 0.5 mole of NO2. So each mole is going to be 0.250. All right, our initial concentration of our products, however, are 0 because they haven't been made yet. Okay, so now we notice that we have a 2. Again, we'll look up here and we'll notice that we have a 2. Right here, right? So that the change is going to be minus 2x because we're going to be losing things. Look here, we have a 2 here. So, but we're not losing, we're gaining this one. So this would be a plus 2x. And there's not anything in front of that oxygen, so we assume it just to be a 1. So that would give us plus x. So again, our reactants we're losing, but our products we're gaining. That's why we have minuses. We're losing here for minus. And we're gaining here for plus. See? Okay. All right, now what we're going to do is we're going to take our amount. So our equilibrium things will be 0.250 minus 2x. This is going to be simply 2x. This is simply going to be x. Now remember, we talked about the KEQ. We set the KEQ in this problem, we were given it. So it's going to be 1.2 times 10 to the negative fifth. All right, so now we need to set up our KEQ equation. So now remember that KEQ is going to be NO. And we have NO, our products. We have a 2 up here. And we have our O2 here. Why do we have a 2 here? Because we have a 2 right there. All right, so let's go ahead and get rid of that 2 there. All right, now we're going to have products divided by reactants. Now reactants are going to be NO2, and we're going to also put a 2 here. Why are we putting a 2 there? Because we have a 2 here. Okay, so let's get rid of that. Now we understand that. Let's clean a little bit of this up before we start actually solving the problem. All right, so we're going to clear some of this out here because it's getting a little busy here. Okay, so I'm going to go over here and do some more erasing because I'm definitely going to need a lot of space for this. All right, so let's get this all cleaned up. And we can get rid of that KEQ because we know what it is. Okay. So let's see here. So now we have our KEQ, and what we're going to do is let's go ahead and let's look at one other thing. So let's see here. KEQ is equal to 2x squared times x. And we're getting these numbers from our table. Over 0.250 minus 2x, and then of course we're squaring that. All right, now we need to look at something here. There's a simple rule, and it's really, really important. We can often throw that out, that part of that out, and I'll show you why. Okay, here's why. You know, our KEQ value was equal to 1.2 times 10 to the negative fifth. That's a really small number. As a matter of fact, it's a whole lot smaller than 0.250. So we can ignore it because it's not significant, right? So it really doesn't have a lot of value for us. For us, okay? So we can ignore that. So let's go ahead and carry this over to the left side here. So now let's go ahead. Now we're going to put in, we are going to put the KEQ value for KEQ times 10 to the negative fifth equals, now 2x squared is 4x squared times x, so give us 4x cubed on the top. And of course, we square the 0.250 right here, and that gives us 0.0625. All right, now we do that, we get 4x cubed equals 7.5 times 10 to the negative 7. We divide it by 4, and then we take the cube root of the entire answer, and x is going to give me 5.72 times 10 to the negative 3. All right, now we're almost done solving this. So this is really, really, really important, okay? Because that's the value of x. All these x's in these tables, we can multiply that number by, okay? So that's important. So let's go and clear all that out. I just wanted to show you that real quick. Trying to keep it neat here. So what I'm going to do is I'm going to erase the right side of the equation. Again, these problems can take a lot of space. And yeah, sure, I could clear the top of the tablet but then we wouldn't have the data table. And so we got to kind of keep it, it's kind of like a catch-22. We really don't have a choice. We got to do it anyway. All right. So let's see here. So we got all the erasing going on. There we go. Everything's erased. That gives you a second to kind of like, oh, what the heck is going on? All right, so we want to know the value. We want to know the value of NO2. All right. So we're going to take the E value. So for the value for NO2, It's going to be 0.250 minus 2 times our x value, which was 5.72 times 10 to the negative third. Our NO2 value is going to equal 0.24 M. I'm sure you're going to be watching this video a couple of times because, yeah, it's interesting. So that's one of our answers. Okay. So now let's do it for our NO value. All right. So we go NO, and our E value for NO is 2, right, times that number, which is 5.72 times 10 to the negative third. And our NO value is going to be 0.011 M. Okay. Last but not least, our O value, our O2 value. Well, notice that it was just X, right? It's just X. So that's just simply the answer. It would be 0.00572 molarity. Or you could go 5.72 times 10 to the negative 3 molarity. So these answers are right, and that's right. Well, that's it for this lesson. I know it's like, whoa, what just happened here? But as we learn this and get further into chemical equilibrium, this will become easier and easier. You guys have a snarly day, and we'll see you back here at Musin Chemistry.